pay somebody a lot of money for a very expensive guitar, and they've hand done it, and everything has been done with a tiny little file and adjusted just precisely. And and this person then gets, $50,000 per guitar because he's someone who knows how to do that. With electric guitars, it doesn't work that way. They've actually added an adjustment. But the problem is they've added one adjustment. As he's going to show, that's not the way to do it. So we originally thought we were going to do a lot of mathematical modeling and come up with a calculation, and we'd figure out exactly how to solve the problem. As he'll show you, once he built his model of guitar with multiple adjustments, so we could measure what was going on, we discovered he'd already solved the problem. So there was no need for math. It was just needed to build his prototype. That's all you really need to do, and he'll show you how it works.
Well, my name is Michael Schwartz. I'm going to talk about optimum string positioning for electric guitar intonation. So what exactly is guitar intonation? Intonation is the accuracy of pitch on an instrument. For a guitar, that means when you play all the open notes and the fretted notes, they're at the correct frequency that they need to be. And as Dr. Jones said, the guitar is in tune with itself. So when you're playing a guitar, every time you pluck a string, you're creating a standing wave. And a standing wave happens when a wave travels through a medium with a fixed point or boundary and is reflected onto itself. And as you fret the guitar, you press the string against the metal fret and you're shortening the string or changing its length and thereby changing its frequency. So there are several parts of the guitar that we're interested in. There's the tuning knobs that change the tension. There is the nut that creates one of the fixed points that I talked about with the standing wave. Here are all the metal frets that change the length of the string as you play. And this is the saddle that is the other fixed point for creating the standing wave. And this is the thing that is adjustable for guitars to be adjusted for their tuning and the types of string that they're going to use. And there are several reasons for poor intonation, and I'll get into them. So, high action. Action is the distance between the string and the fret. The farther it is away, you're going to have to press the string down more, and it's going to cause excessive bending and cause it to go out of tune when you're playing it. The saddle placement makes a big difference. It basically determines how long the string can be, and how well you install this saddle also makes a big difference. As you see, this is a picture of saddle lean. It's leaning forward, so the string is actually going to be a little bit shorter than what it should be. Fret height and spacing. The height makes a big difference. Let's say you don't have an even height on frets. If you're playing something that's really down low, the fret higher up will stick up and touch the string, and you'll actually be playing that fret rather than the fret you're trying to. And fret spacing is exactly what it sounds like. It's the distance between frets. If it's improperly spaced, you're just going to get the wrong note. And fret wear and flat crowning are essentially the same thing. They cause the fret to be a little flat, which causes inconsistent, the string to start at an inconsistent point. And how you play the guitar is also a big deal. In this picture right here, the guy is trying to play this fret right there, and he's playing in between the frets, and when you do that, you have to press the string down really hard to actually have a good contact with the fret, and the string will bend as you're playing it. And in this next picture you can see, he's playing on top of the fret, but he's not pressing directly down, so he's bending the string upward as he plays. And I'm sure most of you have seen a guitar. They don't all have the same thickness of string. And all the strings have different properties which are going to affect the speed of the wave in the string. So, what does poor intonation sound like? So, in this example right here, you're just going to hear a note played on the E string at the 7th fret. Alright. And for this one, you're going to hear the same note, but on a different string. You can hear that they sound very similar, but when you play them together, there is a difference that you should be able to hear. It sounds a little off, and it's more noticeable when you are playing chords. In these examples, you're going to hear a 2-stringed chord you're going to hear one note first, the second note, and then you're going to hear them played together. So this is an example of good intonation. And this is an example of poor intonation. And you can kind of hear the chord is making a wah, 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 wah sound, and that's an example of poor intonation. And sometimes if the producer of music isn't paying too close of attention, you can kind of hear it in some of the music. If you hear at your big rock endings, you hear them hold the chord down and you can kind of hear the beating effect that's going on. So for the setup, I built a guitar. It's very similar to an electric guitar that you normally see. I have the adjustable saddle, I have all the frets, the fretboard, and the tuning knobs. What I did for this was add an adjustable nut. So you can lengthen the string on this side as well as this side and change its position over the frets. This guitar was plugged into an amp, and you can, as you play it, you can use just a tuner. You can use an app on your phone, a nice strobe tuner. You can get the note and how many cents is it off by. And I used, after I got that, I put it in an Excel spreadsheet. So I said how many cents it is off. So we have to kind of figure out what cents are. Let's say you start with a C note. That note has a frequency. And if you double its frequency, you're going to get the next C in the scale or the octave above it. That octave was divided into 12 equally spaced intervals. And out of those intervals, they were all divided into 100 cents. So each interval you go is going to be 100 cents, 100 cents, 100 cents. So for the guitar, each fret you go up is 100 cents. So this was my first testing that I did. I just built it and then just played the low E string. You can see as soon as from the low E, from the 0th fret to the 1st fret, it gets sharp very fast. And then it continues to get sharper and sharper as I play up the fretboard. And in fact, it gets so sharp that as soon as it crosses over the 50, it's trying to be the next note than the note you were actually trying to play. So there was something wrong with the test that I had built. So the first thing that happened was the saddle was not installed far enough back. I talked about the saddle placement is basically determining how long the string can be. I didn't set it back far enough, so the string just couldn't be long enough. And the other problem I had was the distance between the 1st fret and the nut was off. I had built an adjustable nut, but the fretboard was too long to allow that 1st fret to actually be close enough. So to fix that, I had to file the top of the fretboard and push it up against the nut, and the saddle was just a matter of reinstalling it. After I did that, I reinstalled everything, and then I made a saddle adjustment, and you can see my old data right here, how sharp it gets. And this is the properly intonated low E string, and you can see that it's not getting sharp as quickly, not even as much as at all. So what I basically figured out from this was the current method for intonating a guitar was to fix 2 errors with just a saddle adjustment. So they would just put the string on, adjust the saddle, and try to get it as best as it could. But I say that you need to have an adjustment at the nut so you can fix the distance between the nut and the 1st fret and then use the saddle adjustment for all the other frets rather than just trying to use the saddle adjustment to fix everything. So what is next for me? I want to do this for different tunings because guitarists don't all use the same tunings, and I want to use this for different strings because guitarists don't use the same strings. And especially for electric guitar, you have things, some really wild music genres that use tunings that are really low, that require really thick strings, and to get intonation for them is really a challenge when they're recording and everything. And I would like to thank Dr. Jones, my advisor, and Steve Anderson, who helped me build this project, and without him it couldn't have been what it is, and the SSU physics department. Without them, I wouldn't be up here right now presenting this and getting my physics degree.